Okay, so we're going to get into solving equations today. Essentially what we're doing is taking the ratios that we've looked at and solving, any kind of solving equation principles we've dealt with in the past and just putting them together. So some quick review, things that we need to recognize to be able to do this. The cast rule, of course, we need to remember. And the cast rule tells us things like cosine is positive down here, all ratios are positive here, only sine is positive here, and tan is positive over here. I'll also make reference to the various quadrants, 1, 2, 3, and 4. And so we need to make sure we recognize where each one of those is. And basically, we'll be pulling back our special angles, the pi over 6, pi over 4, pi over 3, and using them with our butterfly rule. Remembering that if I have an angle in any of the quadrants other than the first, there is an angle in the first quadrant that is the equivalent, again, other than perhaps the sine, depending on which of the quadrants we're actually starting in. So, should have probably hidden this. Okay, so the questions essentially will be solve for x on an interval. So find all the answers in that area, or in that interval, as I said, that give you the answer we're looking for. Give exact solutions when possible. Okay, and so I sort of did the first one here already. Restarted the video, obviously. So here, if tan x plus 1/2 is 0, essentially what we're looking at is something that looks like some unknown value plus 1/2 is equal to 0. And if we had that, we would subtract the 1/2 from both sides, end up with y is negative 1/2. The exact same thing is true now. The fact that I have tan x instead of just a y or an a or something else does not change anything. This is an unknown value. It's an unknown value that I'm hoping to find. So tan x is, again, subtract the 1/2 from both sides, negative 1/2. To solve that, we do the inverse of tan. Now, tan of 1/2 is not, sort of a key here is, tan of 1/2 is not one of the ratios that we know. So if it were, I would deal with it a little bit differently. Pick up a calculator, punch this in, and the first answer we get is that tan is, sorry, I got that wrong, because I did not punch in the negative 1/2. Hang on. Okay, so when I punch in the negative 1/2, I end up with x being negative 0.4636 radians. Now, that's not that important. What is important is sort of what I do with that. And remembering that essentially I have 4 quadrants, 2 of which have a negative tan, 2 of which have positive tan. So I've got negative tan up here. Got again, negative tan up here, and negative tan down here. This is telling me that in here, that's the size of my theta. And so what I'm really looking for is where are the 2 angles in the interval 0 to 2 pi? So coming around this way, where are the 2 angles to give me that same value of negative 1/2? The first one occurs in this quadrant. The second one occurs down here. And so we recognize that, or hopefully we recognize that, if this is negative 0.4636 up in here, that means I've got 0.4636 in here. And again, the size of this is actually 0.4636 as well. So what that means is if I want to find the actual angle that I'm interested in, the blue angle in this case, the blue value of x is going to be a full pi, so this distance minus that distance. So going all the way past it and coming back towards it. So it's essentially pi minus 0.4636. And the second answer will be the 2 pi that I would have gone had I gone all the way around to there, minus that same 0.4636. So we always want to make sure we're hitting the line that that forms our butterfly. Okay, so the diagram's getting a little messy now, but hopefully the idea is there. So this will be 2 pi minus 0.4636. The calculator gives me the angle that's in the butterfly. What I need to do with that then is make sure that I'm finding the angle between 0 and 2 pi that gets me to a line on the butterfly that's getting me the appropriate positive or negative value for tan. Okay, so just picking up the calculator, the answers will be this and this. Now that question actually ends up being more work probably than ones where I know my angles, because I don't have to do the calculator and the numbers are not quite as messy. So as we continue forward here, again, this question is really just similar to something like this. I have an unknown value squared minus 3/4 equal to 0. What I would do with if it were a y, I'd add the 3/4 over, so I'll do the same thing here. Add 3/4 to both sides, and then take the square root of both sides. And the square root of that, I can simplify a little bit. This is essentially the square root of 3 over the square root of 4, which is the square root of 3 over 2. And this is one of our trig ratios one of our special angle ratios. So what that means is to get cos x being negative 3. Sorry. I should be careful. When I take the square root of both sides here, I get positive and negative answers. And so I don't discount those. And so the two possibilities, essentially, the two initial possibilities, I can have positive or negative answers. Cos x equaling root 3 over 2 gives me an x value of 30 or of pi over 6. The equivalent then is actually the negative pi over 6 for the other value. I guess I could put that in. But again, really what I'm looking for are the values where I am between 0 and the 2 pi. And so if I sort of sketch in the angles I'm interested in, now we want to recognize I'm interested in pi over 6 as being kind of the key in those 4 spots. But because my answer can be positive or negative, I'm actually going to need to get all 4 sections here. I need to get the angle that gets me here, which is the pi over 6. I need the angle that gets me here, which will get me a negative cosine value in the second quadrant, but still gets me the pi over 6 hidden in here. And then, of course, I need to get this and this as well. Because in 2 cases, I'll get the positive root 3 over 2, and in 2 of the cases, I get the negative root 3 over 2. So my possibilities, x is, as we said, pi over 6. In the second quadrant, let's mark these off, maybe in quadrant 1, In quadrant 2, I'm not quite getting all the way around to pi, so I get essentially pi minus the pi over 6. I'm not quite all the way there, which is 5 pi over 6. In quadrant 3, I'm going to get the second negative answer, which is pi to here plus another pi over 6, which is, of course, 7 pi over 6. And then one more all the way around to there. It's not quite all the way to the 2 pi. So it's 2 pi minus the pi over 6. 2 pi is 12 pi over 6. And so essentially, I've covered 11 of those pi over 6. I'm going to stop there. I thought I would do a couple more examples, but they're taking a little longer to go through than I thought. So we'll stick with some easy ones for today, and then we'll maybe put some tougher ones on next day.